Hello, can you solve for the ith root of I or find the value of the ith root of I? This is an Oxford exam maths question. So if you're asked to find the value of the ith root of I, what are you going to do? Pause this video a little and try solving it. In this video, we're going to use some basic rules of indices alongside with the Euler identity to solve this question. So look forward to using those identities and those maths principles. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Now let's get started. From the rules of indices, you'll notice that if I have the x root of y, right, the x root of y can be equal to y to the power of 1 divided by x, right? That is not disputed. So that means this expression can simply give me the ith root of what? Of 1 divided I multiplied by the ith root of I can be 1 divided by I, right? And what will this expression give me? So the next thing you ask yourself is, what do I do from here? Now from this point, I will simply want to multiply I to the power of 1 divided by I by the negative I divided by negative I. I have not changed anything, and what is this expression going to give me? I only did this in order to simplify my expression. Now if I multiply this, I'm simply going to have that expression to now give me the ith root of I multiplying negative I divided by negative I square, right? Great. Now we know all the principles of I when it comes to complex numbers. Do you recall those principles? That if I have my I can be equal to the square root of negative 1, right? So if I is equal to the square root of negative 1, that means my I square, if I take the square root of both sides, my I square is going to give me negative 1, right? Now if my I square gives me negative 1, because if I take the square of both sides, this is going to be squared and this will cut out this, and then I'll have my I to be negative 1. So definitely my I can be equal to negative 1. So if my I can be negative 1, that means I can simply use it in this expression. My I square can be negative 1, I can use it in this expression. So this expression is going to simply give me my I multiplying negative I divided by negative multiplying by negative 1, right? Good. And that expression will automatically give me the solution to become I to the power of negative I divided by 1, right? And that expression can simply be equal to I to the power of negative I. That's all. So that means finally that expression will have, which is the ith root of I, can simply give us the value I to the power of negative I. And if you recall from the laws of indices, if I have a to the power of negative x, this can simply give me 1 divided by a to the power of x, right? So that means the value of ith root of I can simply be equal to 1 divided by I to the power of I. Taken. But this is not the solution. Let's just asterisk this as one important expression we have gotten. So that means if I get the value of this or this, I've already gotten the value of this. Now, this is not the solution. As I said, we need to find the solution of the ith root of I. Now, we are going to use Euler identity. Now, recall the Euler identity. From the Euler identity, if I have the exponent of I pi plus 1, this is equal to 0, right? So that tells me that the exponent of I pi can be equal to -1, right? If the exponent of I pi can be equal to -1, and if you recall, since I square is equal to -1, I can simply turn out this expression to now give me the value that my e exponent to the power of I pi can simply be equal to I square. Good. If that is taken, then I can simplify this expression. To clear out the square root from the right hand side, I can multiply both sides, the power of both sides, by 1 divided by 2. And if I do that, I'll now have that expression to give me e to the power of I pi multiplied by 1 divided by 2, and this will be equal to I square multiplied by 1 divided by 2. So from that expression, 2 will cancel out 2, and then I'll have that expression to give me the exponent value of I pi divided by 2 to be equal to I. That is the unique expression I want to get from that part. Now if you see, I've gotten the value of I there, right? Now I'm going to multiply both sides by the power of I. Remember, what I'm simply looking for is the value of I to the power of I. So if I multiply both sides by the power of I, I'm going to have this expression to give me the exponent of I pi divided by 2, right? And all of these will be multiplying the power of I, and this will be equal to I to the power of I. Is this making sense? I think yes. So if I simplify this, I'll have this expression to now give me my I to the power of I to simply be equal to exponent of I square multiplying pi divided by 2, right? And that is the value of I to the power of I. Now I want you to recall that we have our I square to be equal to -1, right? So if I apply that here, I'm going to have that expression to now give me I to the power of I to be equal to the exponential value of -1 multiplying the square root of pi divided by 2. And that expression will simply give me the value of I to the power of I to simply be equal to e to the power of -pi divided by 2. Good. Now this is one expression we'll take to a high esteem, because that gives us the solution of pi to the power of pi. Now recall from our initial expression that we said the value of the ith root of I is equal to 1 divided by 1i to the power of I, right? From that expression, we have that the ith root of I is equal to 1 divided by I to the power of I, right? So if we have that expression simply gives us this, and that means if I to the power of I is equal to this, so that means the ith root of I will now be equal to 1 divided by the exponent of -pi divided by 2, right? And that is what that is, because the value of our I to the power of I is equal to this. Now how do we simplify this? if I simplify this automatically will give me, recall in mathematics that if you have a to the power of negative x, this can simply give you a to the power of 1 divided by a to the power of x, right? And that is what that expression is going to give you. So this expression will automatically give me the ith root of I to be equal to 1 divided by 1 divided by the exponent of pi divided by 2, right? So if you simplify that, that will give us the value of the ith root of I to be equal to exponent of pi divided by 2. And that simply will be the solution to that math expression. Now from that math expression, you can see that the ith root of I was equal to 1 divided by I to the power of I, and all of this is equal to the exponent of pi divided by 2. And this is the solution to that expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.